Okay, we're going to look at factoring quadratics now of the form ax squared plus bx plus c, where a does not equal 1. Okay, so we're looking at a more complex case. So when we look at factoring, we're looking at going backwards to put this into brackets. So say we have something that's in brackets already. So 3x plus 2 times 4x minus 5. If we multiply this out and just keep everything organized, don't jump too quickly into factoring it or expanding it, then we have this. Okay, so we keep the numbers without actually multiplying them. We keep them set up here. So that's the first 3x times 4x is 3 times 4x squared, plus the outside 3 times negative 5x, plus the inside 2 times 4x, and then the last 2 times negative 5. Okay, now we notice that we have a common our like term here, the x term, so we're going to bring those together. Okay, so still we have this, the x squared term is here, the x term is here, but I'm not actually simplifying the numbers yet, I'm just keeping them as they were. So 3 times negative 5 plus 2 times 4 is the coefficient of x. And then the final term is still 2 times negative 5. When we look at the form of the quadratic here, that's a. 3 times 4 is a. B is this more complex looking thing. And C is that part. So C is multiplying the constant terms. So B is the combination of the outside and the inside together. Okay, so by looking at this, if we look closely, we see that the numbers here and here, so the outside, so the x squared term, coefficient, and the constant term, those numbers are repeated again inside this square bracket for B. Okay? So if we were to multiply A and C together, then this would be a factor because there's a 3 and a 5, negative 5 in there, and this would be a factor. So the 2 and the 4. 2 and the 4 come from the opposite ones. Okay? So that's a neat thing to look at. Okay, so the numbers in A and C all appear in B. B is the sum of two factors of AC. So you multiply A times C together, then these would be two factors. Okay? So if you could find two numbers that multiply to AC and add to B, then you're possibly going to be able to find the numbers that go in here. Okay? So this would then multiply out to that. Now if you're going backwards, notice that AC, 12 times negative 10 is negative 120, and B is negative 7. Two numbers that would multiply to negative 120 and add to negative 7 is negative 15 and 8. And to do this, you look at factors of 120. Start by going with 1, 2, 3, does 3 go in there, 4, 5, and so on. And you'll eventually get to 8 and 15 will be the two factors that when combined give you negative 7. Okay, so 8 and 15. And if we look at this 8 and 15, well, up here, 3 times negative 5 is negative 15, and 2 times 4 is 8. So these two numbers are the two numbers in here. So like I said, these two numbers are factors of AC that add to B, which is negative 7. Okay, so to go backwards, to factor. Okay, so going backwards, factoring. Let's start with this. We know what the answer is already, but let's see if we can do it through this method of breaking up that middle term. Okay? So the two numbers, so multiply to negative 120, which is the product of these two. Okay, so that here is AC. So multiply to AC and add to B. Okay, those two numbers are negative 15 and 8. They're the only two numbers that work. So what we do now is we take and we decompose that middle term. Okay, so we break it up into those two numbers. Remember, those two numbers were right here. So we're going to break it up into negative 15x and 8. These two are equal. The x squared term hasn't changed. The constant term hasn't changed. Negative 7 is the same as negative 15 plus 8. Okay, so we're breaking this up. So if we decompose that middle term into those two, then we can do this. We can now factor the first two and factor the next two. So this is factoring the first two terms here. Common factor is 3 and x. Take it outside. Common factor here is 2. So take it outside that. And if you do this correctly, you'll notice that you'll always have a common factor. In this one, the common factor is 4x minus 5. It's an expression now, our binomial. Okay, so now we're going to take out that common factor of 4x minus 5. When you do that, write down the 4x minus 5. What's left over? 3x plus 2. You put it in that bracket, and that's factored. This method for factoring is called the method of decomposition. Okay, so there's a couple other reasons why this works, and I'm going to show you right now. If you work backwards here, okay, if you're to do, so let's do this, 4x minus 5 times 3x plus 2. Okay, so I'm going to show you a different way of looking at this. If you were to expand this 4x minus 5 times 3x plus 2 out, you would just be going in this reverse order. Most of us would go from this step here and expand it using FOIL to jump right to this step. Okay, and then simplify. You would miss this part here. But if we go right back to the expanding by the distributive law, then you'll see how this makes sense. Okay, so this part here, I'm going to distribute into the first and the second piece of that. So we're treating this 4x minus 5 as if it's a single number. So it becomes 4x minus 5 times 3x plus 4x minus 5 times 2. Okay? Now when I multiply that out, that just looks like this step here. Okay? 4x minus 5 times 3x, that, and 4x minus 5 times 2 is that. Now we expand this, and you get 12x squared minus 15x plus 8x minus 10. Well, that just looks like this part here. And then you simplify, just 12x squared minus 7x minus 10, which is what you'd started with to factor. Okay? So this decomposition method is really just backwards of how you would multiply it out if you went right back to the basics. Okay, if you didn't know FOIL and you just knew the distributive law. So you multiply this out by going 4x minus 5 times 3x, 4x minus 5 times 2. Then you multiply that in and you get this one here. That's normally where we get to using FOIL. And then you simplify to that. So going backwards, really what we need to do, the whole trick here, is to decompose that negative 7x. We've got to break it into two numbers, then we've got to get a common factor for two pieces, and that common factor there is going to be written as one of the factors for the whole thing, and that's what's left over. Okay? So find two numbers that multiply to AC and add to negative 7. Now this method works for any of the quadratics that you're going to do. Okay, so method of decomposition, it works for ones like this. Because the number in front here is 1, AC is just 10. And because the number in the middle is 7, we're going to say multiply to 10, add to 7. Those two numbers are 2 and 5. So before, we could just jump right to the answer, which is x plus 2, x plus 5. And you still can. But this decomposition method works for this, so I'm going to show it. So I'm going to break up the 7 into 2x plus 5x. And then I'm going to factor out a common factor, which is x for that one. Common factor for 5x plus 10 is going to be 5. Now x plus 2 is a common factor of these two. So I write it down, and this is what's left over, the x plus 5. Okay. Same thing for something like this. Well, first, look for the common factor. Pull that out. Okay. AC is negative 6, because A is 1. The sum is 5. The two numbers are going to be 6 and negative 1. So I'm going to decompose the 5x to negative x plus 6x. That keeps it equal. Now, you factor out a common factor here, which is just x, and you're left with x minus 1. Common factor here, which is 6, and you're left with x minus 1. And then you have x minus 1 times x plus 6. Now you can write it in factored form. Okay, so that's when you don't actually need decomposition, because you could have just subbed in the 6 and negative 1 here. Okay, so here's some examples where you need the decomposition method. So let's look at this here. 2x squared plus 5x plus 3. So you're looking for two numbers that multiply. So this is AC, two numbers that multiply to 2 times 3, which is 6, and two numbers that add to 5. So that's the B term. Those two numbers are going to be 2 and 3. So I decompose the 5x into 2x plus 3x. The last term and first term stays the same. Now I take a common factor here, which is 2x. I'm left with x plus 1. Common factor here, which is 3. I'm left with x plus 1. X plus 1 is now a new common factor. So x plus 1 times 2x plus 3, which is left over. Okay. Example 2. AC is negative 12, and B is negative 11. So two numbers that multiply to negative 12 and add to negative 11 are negative 12 and 1. Okay, so I'm going to decompose that middle term of negative 11x into negative 12x plus x. That gives me negative 11x. Common factor is 3x. Another common factor is just 1. Okay, so now you can take the x minus 4, write it out in front, and write what's left over, the 3x plus 1. Another example here. 6x squared plus x minus 15. This is AC. There's B. So I need two numbers that multiply to negative 90, which is 6 times negative 15, and add to positive 1. So negative 9 and 10 would work. Decompose that middle term and go through the factoring. I'll show you one more example. Okay. This one, look for the common factor first. Okay, that's always the first thing you do. 4 is a common factor, so this one ends up being much easier. You don't have to use decomposition. Once you take out that common factor, you get the negative 1, negative 3, and it's factored.